Okay. So we're going to start discussing the timer instruction. Okay. The timer instruction, which is shown here. So the timer instruction has a different structure than the other instructions that we talked about. It uses the T structure, right? So it goes from, let's say you want to use timer 0 all the way to timer 255 on the do more. So you're gonna have available 255 timers. The on delay time for this case, the on delay time is the delay time. This is the delay time. The delay time before the timer done turns on or the output turns on. And the timer, even though it has a lot of information in it, the information that we probably most use are the following. So let's speak for example timer 0, or so let's say timer 0, right? Timer 0, we will use, so we have the timer on delay time. We're going to use the timer 0 dot accumulation value. This is the value that's when the timer turns on, is the value accumulated over time. Accumulated value over time. Even though over here you'll see that in seconds, it's going to be in milliseconds. You're going to have time. This is not a bit. T0 accumulation is not a bit. It is a value. It is a value. And you got T0 dot done. This bit turns on when T0 dot accumulation equals or greater than the on delay time. So 3 seconds or more in this case. And T0 dot TT turns on when the timer instruction is turned on and T0 dot done is not on, which it means that it has not reached the accumulation value or the on delay timer. The on delay time, the accumulation is yet less than. In other words, this on is the same thing as saying T0 dot ACC is less than on delay time. Let's say for a 3-second timer, right? 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds, 7 seconds, all the way to 10. So let's say C0, right? We talked about C0. C0 is going to turn on. Say it's turned on for 1 second, then turns off, turns on for 1, 2, 3 seconds. Three seconds and a half, let's say. And then it turns off, and then turns on for 2 seconds. 3.5, 2 seconds, 1 second. So T0 dot timer timing, which can be used as an input to something in the program. So meaning when timer timing is on, you can trigger something, some action to happen, right? An output. Or use it in combination with other logic. So timer timing, notice that here I am timing. So I am timing. Turns on, turns back off, turns back off. And then it continues here. Notice that the timer instruction C0 turned on again to 1. So this is 1. It's 3.5 seconds, 2 seconds, 1 second. So now this turns on again. But when it reaches 3 seconds, the timer is done. So it turns off at 3 seconds. So this time here, the timer will no longer be on. So I go back here. It's going to continue until it reaches here. Now it's going to turn on again for 2 seconds. After the 2 seconds reaches 2 seconds, it's going to turn off again. Okay? Notice that this time right here, the timing bit turned off. Now let's see something else. Let's check out the timer 0.done bit, which can also be used as a bit. T0.done. Right? When it's done, the output turns on. So let's check this one out. So done bit. So over here was 1 second alone, right? I'm sorry, 1 second alone. So the timer is not done. It has to reach the preset value of 3 seconds. The preset value of 3 seconds. So it continues, not to be on. Turned on again. Turned on again. In fact, let me use another color, the blue one, the blue color. All right. Three seconds. So after the accumulation reaches 3 seconds, now 3 seconds is going to say, hey, the timer is done. All right.
Pay attention, kids.
So now it went back to on. It went back to on until the timer is reset. The timer on delay is only reset for now, right? We'll find other ways to reset it, but for now, when the timer is turned off, the timer is turned off when C0 turns off. So C0 went back off. So timer done was reset. So the accumulation went back to 0 when C0 equals 0. So in here, C0 went back to 0. So now it turns off. turns off, and it continues. Over here it was on for 2 seconds. Timer timing is still on. It never reached 3 seconds, so it kept on going 0. So notice that when timer done goes upwards, timer timing goes downwards. So they are opposite. Okay? They are opposite of each other. And the accumulation will equal 0 when the timer is reset. So when this is turned off, the accumulation will go back to 0. And if T0 done was equal to 1 before that, now it will go back to 0 as well. So let's see it on the program. Okay. Remember, the timer is an output instruction, so you're going to always put it on the right side of your program. So over here, I've added the timer. Your timers are located in this tab. So you can just drag and drop it. I added a test bit here, but just to showcase the timer. I want to add a timer. I just deleted that one. I go to timers. On delay timer, I drag it, I drop it, and it brings me with this setup tool, right, for the timer. Notice that on delay timer, or OND TMR, says here, it says start here if you're not sure what type of timer you want to use. And notice it says it has an output bit. I want to have timer 0. Notice it goes from 0 to 255. I want to add a 12-second delay. Okay? And I have added T0 done and T0 TT. How do you do that? Well, let's say you don't have anything here. Let's delete this. Delete wrong. Delete wrong. Delete wrong. And delete wrong. So let's say I call this timer test. Notice that if you go here, the same thing. You can double click on it and call it a name, timer. Call it timer. You can put whatever name you want. You can also do it from the documentation editor. So you can go tools, documentation editor, and just add it right here. And put extra info, just like any other memory location. Just like any memory location. So now, just to showcase the power of this instruction, and so you guys can understand it, let's delete this, start from scratch, delete, delete. Oh, this is being used. But we can delete this one, C6, C8, test bit. Okay. So now we want to use C6, right? So we go to documentation editor, test bit, C7. So let's see what we're gonna use, how we're gonna use it. So when C6 is on, it starts the timer, it turns it on, and the accumulation starts accumulating seconds, right? So let's do this. So T0 dot done. Notice that me by just putting T0 just already tells me the DN and the TT. We're gonna use DN and TT values, okay? DN and T0 .tt. Okay, I'm using this now as my bit. It is a bit. Instead of using C0, C3, these bits are part of my timer. So when my timer is done, remember, when my timer reaches the accumulation, the undelayed time, the accumulation reaches the undelayed time, my timer done will turn on. In this case, it's 3 seconds. In our case, over here in the program, it's 12 seconds. So going back to the documentation editor, let's call C7, timer is done. And C8, timer is timing. Okay. C6, C7, timer is done. This could be something else. This could be a motor. Hey, I want the motor to start after 5 seconds or 12 seconds. Then that's what we do. C8, timer is timing. Okay. We're going to set the changes because we're doing online changes, and we're going to write them into the PLC. Okay. Now, I'm going to show you a little trick here. Notice that I'm using a test bit called C6. Remember, C's are bits in memory. They're not buttons. So on the simulator, this is a PLC, right? I don't have any button called C because they're reside internal to the memory. They're zeros and one. You can see C memory right here. Right? But I cannot press them and change them some state. So what we're going to do is the following. We're going to open this window called Data View. We're going to put it in select mode. We're going to write C6 here on the first on the element column. Notice that it says test bit. This is C6, right? And on the edits, I want to put on, and I'm going to write them. If I want to write just this value, I go here. If I have multiple values in here, then you can write multiples over here. So if I have multiple values over here, and you change them on values, you write them over here. So now I'm going to write them in. Look at this. I write it, turns on, timer is timing. When the timer reaches 12 seconds, so 6, 8, 9, 10. This one's going to turn off, and this one's going to turn on. And that's what happened. Now, if I turn it off, the accumulation is going to go reset back to 0, and timer done is going to turn off. Turned off. It reset back to 0. Okay. Now, if I turn it on, immediately timer timing turns on, right? Just like our table. If I turn it on, immediately timer timing turns on. Okay. Timer timing is not going to go down, it's not going to go off until it reaches the undelayed time. Okay, the undelayed time, we have set it up there. So let's play around with this now. See, undelayed time, we're going to turn it on. Bam. Starts timing, right? Notice that done bit is not on yet. If I turn it off before, it resets everything, and timer timing turns into 0. Now, if I turn it on and leave it to time all the way to 12, when it reaches 12, timer timing is going to go off. It's no longer timing. The accumulation is increasing, but the timer itself, its delayed time is already being reached. And it's going to turn off, and this one's going to turn on. And that's what happened. Now, I'm going to show you another trick. All right? So we've always been using bits, right? So notice that I have this bar right here, which are contacts as well. I got them right here. Okay. So you can use them as well for the timers or for any type of value, right? So let's say you want it when is greater than and equal to when T0 dot ACC is greater than, now remember the accumulated value is going to be in milliseconds. So you just, see, instead of putting like 3 seconds, so let's say if you want to turn on an alarm after 3 seconds saying, hey, you're about to reach your time value. You want to turn on an alarm before it reaches the done, before it's done. You cannot put 3. Since it's in milliseconds, you're going to have to put 3 additional zeros. Okay? Now let's say you wanna turn on something between 3 seconds and T0 dot ACC, between T0's ACC and 5 seconds. You see, 5 seconds, I added 2 zeros. So notice every time that once I go past 3 seconds and I'm lower than 5 seconds, basically, I'm doing this. In math, this is like this. 3 seconds and 5 seconds. In between these two values, in between 3 seconds and 5 seconds, I want to turn on, let's say, Y6 or something like that, right? Let's go to documentation editor and just declare this. It says Y3. Let's use Y3. But I also want to turn on an alarm when I am equal to, so notice that over here I have greater than, right? Not equal to. So T0 dot ACC is equal to 5,000, but let's let's change this. Let's change it. Let's change it to greater than or equal to. There you go. Now you see how I change it? I change it by double clicking on the. I'm selecting the instruction. I double click it and it changes. Okay, greater than or equal to 5,000, but less than T0.ACC 10,000, which is 10 seconds. 1, 2, 3, and then 10 seconds. T0.ACC Y4. Okay, I already had declared these two already. So now I'm going to set the changes, write to the PLC, and hit OK. So notice, right now, accumulation is 0. Accumulation is 0 because C6 is off. When I turn it on, yes. When the accumulation reaches 3 seconds and it's less than 5, turn this one off. You can see I am playing around. Look, when it reaches 10, you turn it off. When I hit over here, turn them off. Both of them are off. Accumulation is 0. So I can use this T0 for logic, for conditions. So T0 is greater than this, less than that, equal to this. So whenever the timer is accumulated value, look, when it reaches 3 seconds, it's less than 5, it's going to turn on. When it reaches 5 seconds, turns off. 5 seconds and 10 seconds. There you go. I hope this explains pretty much the timer. We used these timers a lot in the industry. You can see when I turn it off, it resets. So I'm always resetting the timer with this. Please write your questions, write your doubts down. It's very important that you write your doubts down. Okay?